Welcome. This talk is called How Large of a Macaroni Drawing of the Mona Lisa Could You Make If You Turned All the Matter on Planet Earth into Macaroni? To motivate this study, consider the chemical composition of planet Earth. Earth is mostly iron, oxygen, silicon, magnesium, and some other trace elements. Now, in the event of a cataclysmic nuclear fission event, it is not unfeasible that the entire Earth would be turned into carbon, hydrogen, and oxygen. It is reasonable to assume these elements would take the form of a polysaccharide chain, such as the carbohydrates that constitute elbow macaroni. It is then natural to ask the question, how large of a macaroni drawing of the Mona Lisa could you make if you turned all the matter on planet Earth into macaroni? Before we delve into calculations, we must attempt to understand the aesthetic language of macaroni art. As a case study, we examine Crafts to Do with the Boys from Dr. Ann Dong et al. On Pinterest. Now, Dong et al. Utilizes the traditional elbow macaroni, but they also challenge the boundaries of the medium by including elements of penne, whole wheat spaghetti, rotelle, conchiglie, and an unidentified bean. Note that Dong et al. Missed the opportunity to make an elbow out of elbow macaroni. In this work, we assume that our macaroni art will be entirely formed from the traditional elbow macaroni, and that our artist will not be so brazenly talentless. We begin our calculation with the mass of Earth, 6 times 10 to the 24 kilograms. In half a packet of my roommate Sam's macaroni, I counted 256 pieces. This constitutes half the labeled weight on the package. We can then conclude that if the entire planet Earth were turned into macaroni, there would be 6.73 times 10 to the 27 pieces. Using the nutrition facts, we find the caloric value of this quantity would come to 2.21 times 10 to the 28 calories, or the energy equivalent of a billion atomic bombs. We now know the Earth macaroni equivalence cardinality. The question remains, how do we turn Leonardo da Vinci's Mona Lisa into macaroni? To answer this burning question, we turn to Fourier's transformation. The two-dimensional discrete Fourier transform gives us the frequency decomposition of an image. In the frequency domain, we can apply a high-pass filter to tease out the sharp edges of an image. Then we apply the inverse transformation to obtain a new picture. Applying this procedure and then turning the filtered image into a binary array, we can get an idea of what fraction of space we need to fill to recreate the Mona Lisa's likeness. This crucial metric, also known as the Mona Lisa macaroni art filling factor, comes out to 6.78%. Our final step is understanding the packing density of elbow macaroni. In this study, the surface macaroni density, denoted sigma, was experimentally determined. The area of the macaroni Mona Lisa and the number of macaroni noodles are related by the following equation. We calculate this area to come out to 2.31 times 10 to the 25 square meters. Just how large is this? This dot in the middle of the screen represents the Sun. Here's the orbit of Uranus, with a radius of 1.78 billion miles, and an orbital period of 84 years. This orbit would just about encompass our macaroni Mona Lisa. She would be 3.65 billion miles long. That's 40 times the distance between the Earth and the Sun. Light would take 5.5 hours to traverse her. The Earth is not pictured in this diagram because its orbit would be too tiny to make out, and also because it would be turned into macaroni. This study has immediate applications in cosmology, contemporary art, and the culinary sciences. Some lingering questions we have include, how would taking into account a cheesy sauce, perhaps a French Mornay, affect the results of this study? Furthermore, this work raises fundamental questions on the structure of space-time. Notice that the toroidal model of space-time closely resembles two pieces of macaroni put together.